Hello, my name is Salvatore Corona. I'm Solution Executive Environmental with Bentley Systems. And today we're going to talk about a really interesting aspect of GINT rules, a sample GINT rule we call gra005. So the people that wish to quickly create an architecture for GINT rule on save in input, this is a place you want to be. Really accelerate getting into writing save procedures, which are the most common procedures with GINT rules. So the focus is going to be on automatic generation of the code, the data validation, and the calculations for a very simple GINT rule, but it sets up a template for all of the GINT rule on saves that you would want to write. So for references, we have the GINT rules documentation, and you can get that in GINT let's go into GINT and take a look at that. Go under Help and Manuals, and this is the one we want here, GINT rules code. It's quite a bit of documentation. Don't be intimidated by the size. Most of it is reference material, and there's a very long tutorial on generating the code that we post for the GINT rule sample called gra001. And the other thing to look for are the GINT rule samples. We have 31 sample projects now. This is the link, but let's go there through GINT, under Help, Internet Links, go to the GINT webpage on the Bentley site, go to Communities, and there's quite a bit in Communities. The first thing you'll see is a forum. You're all welcome to post questions and comments, and people from Bentley will respond, but more likely people in the community respond. Then if we go to the wiki, lots of free downloads here, reports and symbology and lots of items. We're going to look at GINT rule samples, and here they are. The description, if you want more of a description, you just click on the full description, and it's all here. And the files are here in the zip. And it will tell you what version of GINT you need here. Oops. So, for those beginning to write GINT rules code, probably the hardest initial part is setting up the code architecture. There's a lot of things you need to do before you can even start to write your code that does actual work. And gra005, which is one of the samples on our website, will generate that architecture code for you. And then you can concentrate on writing the code that does real work. So we're going to be looking at a simple save procedure. It calculates the difference between two dates and between two numbers. All right, let's get into it. So here's this table that we've set up. We've got a start date and an end date of some test, just generic test. And we want to know the total minutes in between. Now certainly on a report, we have functions that will do this for you, but you want to see it in input. And we also have a reading start and a reading end, and we're going to take the difference. That's all we're going to do. And where you need to start is here, under GINT rules code. There are lots of different ways of coding. If you've done any coding before, you know there's many ways to code, as there are programmers, actually more. And we like to break things up like this. We have table procedures, which are directly referenced from your tables. We'll look at how that's referenced in a moment. And then common procedures are procedures that are shared between different other procedures and modules. You can have multiple modules. We like to also add an add-ins module, and add-in procedures if you have add-ins in your library. So if you have no Git rules at all, you will need to do a bit of work. We do recommend setting up this structure, and in common procedures we recommend this structure in the declaration section. The gra005 does assume you have these two variables as public variables, and they're declared here. And this one procedure called initFields function B. So you can get these from most of our samples, just to show you. And then one more thing, and then I'll show you how to find these. Back to list and table procedures. All main modules that you're referencing from within the database have to have a public submain. This is where everything goes through. And in this procedure, we're putting the contents of the grid data. All of this data here goes through a grid data object called data array. That can't be worked on directly. You need to put that into this two-dimensional array, which was defined in the common procedures. And then every procedure needs to know how many rows there are. So that is the upper bound of the second element of this data array. The first element being number of columns, and then the second one being number of rows. And then we call the appropriate procedure. And then when you're done with your magic, it comes back here. The data array that you've been manipulating goes back into the grid data array. And then we check for success. If you've set an error column, I'm going to show you how to do that. So the error column being the column number here. If that's 0, that means there is no error and the program will save your changes. If you do set an error column, the program will not save and will not let the user out until the error is corrected or they undo their changes. So all the procedures will need to do this. So this is your base. If you're starting Git rules from scratch, you have no Git rules, recommend we could have put this all into one module, but we'll put it into two. We think it's good practice. We know it's good practice. So but what you call those procedures are up to you. And so you want this and this one procedure here, and then the table procedures or whatever you're calling it, we want this public submain and a link to the common procedures. That ties the two modules together. This lib include, and this is all covered in the documentation. So where are you going to get this information? You don't want to have to type this from the AVI you're looking at. You can open up any one of our, or most of our rules sample procedures, and I'll just bring up one. I'm going to change library to gra001. Open that up. And we go into Git rules code, and you would take this and then just change this lib include to whatever you're going to call your common procedures module, and you put that in your table procedures. Oops, sorry. And then we go into the common procedures, and you take this plus the init fields. You take this procedure and copy that in. So one way is to change that library, copy and paste into Notepad or some ASCII editor, open your library back up and create these things. The other way to do it is to use our libmerge copy utility. Merge it in, rename them, take out the things you are specific to GR001 besides those items I pointed out, and then you have a starting point. Okay, so we have our starting point. Now we want to write the architecture for this procedure, and we need gra005. The A means it's an add-in. You can add your own menus using Git rules. So we're going to switch to that. The other possibility, you can merge, if you're going to use it a lot, merge gra005 into your library. So it's available to you at all times. And you will see an add-ins here. There's gra005, and there are two procedures that can set up, types of procedures that can set up the architecture for. One is a get rules procedure on empty data set. For example, you've got a sample table. When you enter the sample table and there's no data for the current borehole, that will trigger this event, the procedure on empty data set. And then you can call code that will pre-populate your sample records. Maybe you have a sample at always at 1.5, 5, 10, 15, 20, 30, 40. You can pre-populate those. And then there's code in there that you can, on save, it will remove the ones you didn't use. That's all covered in other get rule samples, and it's covered in the documentation. For this presentation, we're going to be looking at the get rules procedure on save, which is a much more common procedure. So we're just going to click on that, and it's telling you what it's going to do. It's going to generate the skeleton for a get rules procedure on save for this table. So if you happen to be in the wrong table, you would cancel and move to that table and run it again. So in our case, it's correct. And we're going to call it procedure name. We're going to call it test save. Written by me. And description calculates the differences between the end date and start date and the end reading end and reading start. Don't worry about getting this right because you'll be able to edit it once this is all done. Remember, procedure name can't have any spaces. Basically letters, numbers, underscore. Now it wants to know what fields you're going to be referencing. By referencing, meaning the code will either read the field or write to the field or both. And we want all of these. So we're going to mark all. We're either going to be reading or writing all of these fields. Now it wants to know what fields are you going to read. Now we are going to read the start date field, but it doesn't show up here because it's a required field. So the program knows it's going to be there. So it doesn't even ask you. So we do want the end date, the reading start, and the reading end. These two we're not going to be reading. We are, however, going to be writing to them. So there and there. That's all there is to it. The code architecture has been generated, and we've stored it to the Windows clipboard. So we're going to move to where we want that code, and we're going to paste it in. And click OK. We're going to go into Get Rules, Get Rules Code, and we got to switch libraries. We're still in gra005. If we had merged it, that wouldn't be the case. So we're going to change library and change back to the library we're working with. There. And go into Get Rules Code, Table Procedures, and this is where we want to put it, and we'll paste. And the code architecture is all handled for us. Let's go over this. So remember, it's going to go through submain. It's going to call the appropriate procedure. It's going to be this one. Here's where you can change any of that description you want. It's a little bigger. First thing it does, it puts in the names of all the fields you're going to be referencing and puts them in constants. This is not strictly necessary. This is good practice. It puts all of the field names at the top of the procedure. And the procedure could be quite large. So instead of looking for what fields 6 months from now, if you want to look at the code and see what fields am I using, it may not be all of them. You might have 30 fields and only use 5. Here they are in a list. If you ever change your field names, let's say you decided for some reason to name this date ended, you can just change it here. And no matter how many places it's used, nothing else has to change because we're going to be referencing the constant from this point on, not the actual name. Let's put this back. Next thing it does is it puts in all the variables we're going to need. We're going to need a time variable for the end date and a time variable for the start. These fields are double precision numbers, so it puts that in. And it knows this by looking at the field data types. And then the column position. We'll talk about that in a moment. And finally, some of the fields for some of the other data we're reading. Now notice that end date here is in two places. It says a string and as a date type. And the reason for that is the end date is not required. So we can't just read that into a date field or a date variable, because if it doesn't exist, you can't put empty into a date. The program, the compiler will complain. It will not execute that line. So we have to put it into a string variable temporarily, make sure there's data, and if there is, then we can put it in date. Same with the reading end and reading start. Those are both numerics, and we also have the double precision variables up here. We don't have a S start date because it's required. So we know it's always going to have value, so we don't need a temporary string variable. And in terms of the naming, we have these prefixes. We have all of our naming conventions are laid out in the manual. You do not have to follow our naming conventions. And if you don't like the way this is set up, you can actually go into gra005. It's a Git rule. It looks just like this. And you can change the way it behaves. So you can make it format your variables any way you want. Okay, so the first executable code we're running is here. The first thing we're doing is we need to know the column positions for each of the fields that we're either reading or writing, all the reference fields. So remember, you're getting past a two-dimensional array, and we need to know the column numbers for each of these columns. Now, this is not column 1 and this is column 2. There are some hidden columns here. Depending on your table structure, you could have as many as 5, 6, 7 hidden columns. They could be foreign keys. And so you don't know what this number is. Further, even if you knew that this was column 4, you cannot use that because the user may do this to you. And now it's not column 4 anymore. So you have to run through this procedure every time because the column numbers may change. It's also a check to make sure these fields still exist. If someone renamed or deleted a field, this code won't run. If any of these cannot be found, the program exits, and this procedure will give it an error message. So what we're doing here is we're passing in the field name. It returns the column position. Name, position, name, position. You just do that once. And then you're going through each of the rows. Remember, glnum rows was found here. It was done once. And no matter how many procedures you have in here for different tables, they all need this information. So it's just done in the main procedure. So we're walking each of these rows and pulling out the start date, the end date, the start reading, the end reading. And then your code here, what are we doing with it? And then your assignment code. So let's fill in the blanks here. So one thing we want is the total time. Let's grab that variable. And you would have to know this. It's the date difference. There is a function built into the compiler. If you've ever run any kind of VBA code or VB, date diff is a built-in function. You'll find that in a lot of places. You put in the interval, and we want minutes, which is n. And I'll show you where to get help on this. The first item, which is the start date, which is right there. Now, just for, this would work. We could put the end date in here as a string. It's not good practice. We really should convert it first. So we're going to say end date equals C date. We're going to convert to date of S end date. Now, we're going to revisit this in a bit because that's not complete. This will work in this condition. So this will take the date difference between these two dates and return minutes. Now if you want help on date difference, just put the cursor in the middle and press F1. You will not find this in Gint help. You will find this in the compiler help. And it tells you what these things mean and what magical letters you put in to get month or quarter or day. So you don't put in M, that will give you the difference in months. It's N for minutes. Okay, and then when that's figured out, we put that into the total time position here for the current rel. And again, we want to do the conversion. This is a number. This is all of the data array is text. It's all string variables. So we want to convert this to a string. Right? And another way, if you wanted so many decimal places, you could say format. And we could format it to 2 decimal places. You could also do that. We're just going to leave it and put in C string. Now we want the difference in the time. So the page up here, D reading start equals C double, converting the string version, which comes out of the data array, to a double precision number. And we'll do the same thing with end. And finally, we will get the reading amount equals D reading end minus D reading start. And anyone who's done decoding can see all kinds of places where errors can occur here. They can, and we will come back and handle the validation in a bit. So there we go. And that's the entire procedure. Let's see if it works. So that code doesn't do any work unless you tell the program where to execute it, when to execute it, under what conditions, what event. We have a number of events. The main group of events is under the table properties, get rules. Here are all the events you can run in tables. The empty data set event, after updating the grid on save, which is the most common, and that's the one we want. It'll show you. Notice it didn't show the common procedures, because common procedures does not have a public sub main. So it knows not to show that in the list you can pick. And here we go. We want test save. So every time you save in this table, it will call your procedure. And so just to finish off this list, we have a get rules procedure on deletion. So if you delete a record, if you have code here, if you have a reference to a procedure, it will call that. Then your code can look at that record and maybe look at who's logged in and say, hey, you don't have a right to delete records. And you can abort the deletion. And a get rules after save, this is used in rare cases where you have to interact between 2 or more tables and calculate information from those multiple tables and store data in those multiple tables. You can read about this in the documentation. And then a get rules procedure on leaving a tab. When I move from test to point, do I need to do something? And again, there's documentation on all of these events with examples in the manual. All right, so we've got that, and I'm going to make some changes. I'll just change them all by just deleting 2 empty fields here. And now I'm going to save, and it magically puts in the amounts. So this is the number of minutes between these 2 dates, and these are the amount of minutes between those 2, and these are the reading differences. That's all there is to that. And of course, these are very simple rules, but the architecture is the same, regardless of how complex your rules are. That core part that we just coded, that's what will change. And it might be a few lines long. It could be pages and pages long. Now, we're not done. This will work if the user types in everything perfectly. But let's say the user does this. Let's say the user didn't put in the end date. Now I'm going to try to save. It throws an error, type mismatch. We're trying to convert an empty string to a date. Can't do that. And the same would happen if I was, let's put this back, and take this one out, save. Same problem. We're trying to convert an empty string to a number. It doesn't return 0, it returns an error, as it should. So put this back, save again, and everything's fine. So we need to put in some data validation here. So the first thing we're going to do is right here, we're going to say if len s data, copy that, greater than 0, meaning there's value in there, then we will do this. And we'll put this inside. And same here. In this case, we're going to say if len greater than 0 and len greater than 0, then okay, now let's try it. Let's do this and this and save. Nothing happens. Now you can decide that if those are blank, you want to clear these. But if that's the case, if these will only be calculated with these have data, you might, your test may be that you might want to force the user to fill in these values. So we could make this required and these two required. Then we don't need that error checking because they're always going to have values. If that's the case, that you're forcing the user, they have to have these raw data fields, make them required, and make these fields read-only. Do that this way. You make it read-only, and now the user can't actually type in here. Matter of fact, it skips over it. Won't even let them in. We've set it up here in this way because the coding is more interesting. And two, let's say you've got legacy data where you don't have raw data. You just have final results. Well, then you want to leave this open so people can type just the final results. So this is a more complex case. In the case where they just have to have data, you don't need that kind of validation. But even in that case, you could have a problem. Let's say instead of putting 935, the user inadvertently typed 735. Save, and now you have minus 55 minutes. Now maybe that's legitimate. I tend to doubt it. Generally, when you have a start date, end date, the end date needs to be after the start date. So we need to put in some other validation. So if the end date is greater than 0, if it has data, there's the end date. Now we put in another check. If the end date is less than or equal to, we're going to say it can't equal. You may decide, in your case, it can equal, then we just have less than. We'll say if it's less than or equal to the start date, then we have an error condition. And we're going to set an error message. And we're going to put end date must be after start date. And we're going to set the error column equals the position of the end date, which is that. And we're going to set the error row as the current row, which is L row, which comes from here. And we're done. We exit sub. I'm going to make them fix it. Oops, forgot the E here. There we go. All right, let's try that again. And we're going to delete that and force a save. End date must be after start date, and it brings us back to the right position. And now you can't get out of here. You can't even exit the program. It'll yell at you until you fix it or undo your changes. So I'm going to fix it and make that 9. And we have the same problem here. 18, and we get a -4. Now, maybe this test, that can happen. I'm going to say it can't happen in my fictitious test, so we're going to put another test here. And we're going to say, we have that. We have the reading start, reading end as numbers. If the reading end is less than, and we'll allow it to be equal. Your test, it may not be. If it's less than the start, same thing. Might as well just copy this down. We'll change the reading end must be greater than or equal to reading start. And the error column would be there, and the error row. Okay, save. All right, delete this, save again, and they won't let us. Let's fix that, save, and it comes back. There are other error conditions you might want to consider. For example, what if they only put in the reading start? Do you really want to let them get away with that? Why would they put in a start and no end? I guess I could see a case for that, in that maybe they get the start readings and 2 months later they have to get the end reading. That's a possibility. But assuming that's not the case, chances are you don't want to let them do that. Probably want to force them to. And you don't want to make it required because you want to be able to put in reading amounts manually if you don't have the raw data. So the way to fix that, if these two both have a value, we go through this line of code. Otherwise, if either has value, so we can do it very quickly with this. We could do it this way, actually. Just say or. So they say else if. So we know they both don't have values, otherwise it would have gone through here. But one of them has a value, so that's not good. So we want to get rules. Again, error. We're just going to copy this. And indent it back. There we go. Supply reading start and reading end, or neither. And you can put the position wherever you want. We don't know which is wrong. Same in this case. We don't know which one is wrong. Could have been a reading start or end. We'll get them in the general vicinity. So let's do that. Delete that and save, and supply reading start and reading end or neither. I'll delete both, and it lets me save. Put this back, and just to show you, it's not always going to row 1, it's going to the appropriate row. And it goes to that one now. And we could get more sophisticated here and say, just to finish this off, we could say if equals 0, if that one's blank, then the error column is that, else the error column is I position reading end. So now it'll go back to the appropriate column. So if I delete this and save, it brings us here. If I delete this one and save, it brings us there. Let's go, it doesn't matter. Okay. So that is the whole process. And most of the time I've not been speaking about the architecture, I've been speaking about the actual coding of things, of processes like this. The actual architecture was that gra005, and it generated that very, very quickly for you. And then from that point on, you get to do real work in the coding and not have to worry about setting it up. Go back here. So in summary, if you've got no Git rules to start, you need to create those two modules. And with the chunks of code, I showed you the public sub main in the table procedures, and then the init fields function, along with the header information. And you can get that from, recommend GR001, not GRA. GRA001 is an add-in. And then merge in or switch to gra005, and you run it. You move to the table you want to create the save rule, and then you run it. And then you paste the code in the appropriate module, write your validation calculation and assignment code. And you're done. Thank you very much.